Hi folks, this is Vardhan from Edureka. Today I'm going to tell you why Docker is the hottest technology in the DevOps scene. Docker is a software containerization platform. If you don't know what that is, then you don't need to worry because I will explain it in detail in today's session. Now before we move forward, let me show you the agenda for today. In the first section of this video, you will understand the subtle differences between virtualization and containerization, and you will learn how containerization is an upgrade to virtualization. I will then tell you what is Docker and show you a comparative analysis between virtual machines and Docker containers, proving how Docker comes out on top in every aspect. After that, I will talk about Docker's working architecture. The second section of this video will be a practical hands-on session where I will show you how to build your own images and spin containers out of them. This also happens to be a practical lab in Edureka's DevOps course. So first let's talk about the difference between virtualization and containerization. Virtualization is the technique of importing a guest operating system on top of a host operating system. This technique was a revelation in the beginning because it allowed developers to run multiple applications in different virtual machines, all running on the same host. This eliminated the need for extra hardware resource and enabled backup, allowing for easy recovery in case of failure conditions, thereby lowering the total cost of ownership. But virtualization has some shortcomings. Running multiple VMs in the same host OS leads to performance degradation. This is because of a guest OS running on top of the host OS, which will have its own kernel and its own set of libraries and dependencies. This takes up a chunk of the system resources. Another problem with virtual machines which uses virtualization is that it takes almost a minute to boot up. This is very critical in case of real-time applications where fast processing is a priority. This, along with the fact that scaling up the number of virtual machines being a tedious and costly affair, gave rise to containerization. But what is containerization? It is a technique of bringing virtualization to the operating system level. While virtualization brings abstraction to the hardware, containerization brings abstraction to the software. Do note that containerization is also a type of virtualization. Containerization is more efficient because there is no guest OS here. Binaries and libraries of containers are run on the host kernel, which makes processing and execution very fast. Even booting up a container takes only a fraction of a second. Because all the containers run on the same host, they are lightweight and faster than virtual machines. Folks, to make this video more interactive, I will post a number of questions and expect answers from you. I will do this to check if you understood the concepts properly. You can pause the video for a few seconds to read the question and you can put your answers in the comment box. If you don't know the answers, you can rewind the video to the previous slides and learn every minute detail and then comment your answers in the comment box. This is the first of the many questions I will be asking you today. Which of the below options is incorrect? Containerization is replacing virtualization. Containerization brings process level isolation, and hypervisors manage the virtual machines. The correct option is containerization is replacing virtualization. That is because this statement is not correct. It is not replacing virtualization. It is just the next step in the evolution process. There are still many circumstances where virtualization is a better option. If you want to run an application in a Linux machine, and if you have a Windows machine, then you cannot run the application. And at that point of time, hosting a Linux VM on your Windows machine would be very beneficial. I will ask you many such questions in this video. So watch the entire video to have fun while learning. Now let's see what is Docker. Docker is a software containerization platform which packages your application and all its dependencies together in the form of containers so as to ensure that your application works seamlessly in any environment, be it development or test or production. This means that each application will run on a separate container and will have its own set of libraries and dependencies. This also ensures that there is process level isolation, meaning each application is independent of other applications, giving developers surety that they can build applications that will not interfere with one another. As a developer, I can build a container which has different applications installed on them and give it to my QA team who will only need to run the container to replicate the developer environment. You may have questions like how does this help? It helps because the QA team need not install all the dependent software and applications to test the code, helping them save lots of time and energy. This also ensures that the working environment is consistent among all the individuals involved in the process. The number of systems can be scaled up easily and the code can be deployed on them effortlessly. Now let's learn in detail the benefits of Docker over virtual machines. The image you can see on a screen is very typical of how Docker is when compared to virtual machines. The space consumption in case of a virtual machine in Docker can be related to the comparison of space occupied by an elephant and a rat. Starting up a virtual machine and starting Docker can be related to the difference in speed between a tortoise and a cheetah. And when it comes to integration, virtual machines will say, "What on earth is integration?" Whereas Docker can be comfortably integrated with many DevOps tools for automating manual processes. Now let's talk about this in more detail. Consider a hypothetical situation where I have a system with 16 gigabytes of RAM and I have to run 3 virtual machines on it. To run the virtual machines, I divide my RAM such that my first VM gets 6 GB of RAM, my second VM gets 4 GB of RAM, and my third VM gets the remaining 6 GB. Now, even if my first VM uses only 4 GB of RAM, my second VM uses only 3 GB of RAM, and my third VM uses only 2 GB of the allotted 6 GB of RAM, then I will be wasting 7 GB of RAM in total. This 7 GB of RAM cannot be used for setting up a new virtual machine because once any virtual machine is allocated memory, it cannot be taken back later. This is a major issue because RAM is a very costly hardware. Now, how can I avoid this problem? If I use Docker, my CPU will only allocate to the Docker container exactly the amount of memory that will be used. My first container will be using only 4 GB of memory, the second container will be using only 3 GB of memory, and my third container will be using only 2 GB of memory. Since there is no RAM that is allocated and unused, I save 7 GB of memory by using Docker. I can even create additional containers from the leftover RAM. Now when it comes to startup, virtual machines take a lot of time to boot up because the host system needs to be set up first, which will then run the hypervisor, which will in turn set up the different virtual machines. This is time consuming and it will prove very costly at times when quick startup of applications is needed. In case of Docker, since the container will be running on your host OS, you will be saving precious boot up time. This is a clear advantage over virtual machines. So consider a situation where I want to install different versions of Ruby on my system. If I use virtual machines, then I will need to set up 2 different virtual machines for running the different versions. Each of these will be having its own set of libraries and binaries while running on different guest operating systems. Whereas if I use Docker, even though I will be creating 2 different containers where each container will be having its own set of binaries and libraries, I will be running them on my host OS. Running them straight on my host OS makes my system lightweight and faster. This is the advantage with Docker. But what about integration? Integration of different tools using virtual machines may be possible, but even that possibility comes with a lot of complications. I can have only a limited number of DevOps tools running in a virtual machine. As you can see from the screen, if I want many instances of Jenkins and Puppet, then I would need to spin up many virtual machines because each virtual machine will have only one running instance of these tools. Setting up each virtual machine brings with it infrastructure problems. I will have the same problem if I have to set up multiple instances of Ansible, Nagios, Selenium and Git. It will also be a hectic task to configure these tools in every virtual machine. This is where Docker comes to the rescue. Using Docker containers, we can set up many instances of Jenkins, Puppet and many more, all running in the same container or running in different containers which can interact with one another by just running a few commands. I can also easily scale up by creating multiple copies of these containers, so configuring them will not be a problem. Summing it all up, I can confidently say that Docker is a more sensible option when compared to virtual machines. To learn more about how different tools can be integrated using Docker, please watch our video titled DevOps Tools. You can find the link to that video on your screen and in the description below. Folks, it's time for our next question. Suppose I have a system with only 4 GB of RAM and I want to run 4 instances of a particular DevOps tool, then which of the below is the best choice? 4 VMs with 4 different instances of that tool, 1 VM with 4 different instances of that tool, or 4 different Docker containers with different instances of that tool? Do take your own sweet time to answer this question. You can put the answer in the comment box, which I will validate at the earliest. And the correct answer is Docker containers. That's because Docker containers utilize very less RAM when compared to virtual machines. Another advantage here is that these 4 Docker containers will be running on the same host operating system, making your system lightweight and faster. And the other thing is that virtual machines cannot be used here because each virtual machine requires at least 1 GB of RAM, and we do not have that much resource. Since our RAM is only 4 GB, we cannot use a complete 4 GB on virtual machines. But in case of Docker, there is no need to pre-allocate RAM, and hence Docker is the obvious winner here. So who can use Docker? The answer is everybody. Docker is designed to benefit both developers and system administrators, making it a part of many DevOps toolchains. Developers can write their code without worrying about the testing of their production environment, and system administrators need not worry about the infrastructure, as Docker can easily scale up and scale down the number of systems for deploying on the servers. So how is Docker used in DevOps? Docker is used 90% of the time in the continuous testing phase and probably 10% of the time in the continuous deployment phase. Docker plays a major role in the continuous testing because it sets up the testing environment. It is also used to deploy the code to production, and that's how it plays its role in the continuous deployment phase. Let's now look at how Docker works. Docker Engine is the heart of the Docker system. It works like a client-server application which uses a server, which is a type of a long-running program called a daemon process, and a command line interface client. The REST API, with a combination of a socket IO and a TCP IP connection, is used for communication between the CLI client and the Docker daemon. In a Linux operating system, there is a Docker client which can be accessed from the terminal and a Docker host which runs the Docker daemon. We build our Docker images and run the Docker containers by passing commands from the CLI client to the Docker daemon. But in case of Windows or iOS, there is an additional Docker toolbox component inside the Docker host. This Docker toolbox is an installer to quickly and easily install and set up a Docker environment on your Windows or an iOS system. The Docker toolbox installs Docker client, machine, compose, kitematic, and VirtualBox. Okay, now it's time for the next question. How does the communication happen between the Docker client and the Docker daemon? Is it through the REST API? Is it a combination of the REST API and the socket IO? Or is it a combination of the REST API and the TCP? Or is it just the combination of the REST API, socket IO, and TCP? You can pause the video here and put the correct option in the comment box, and then resume the video. And the correct answer is the combination of REST API, socket IO, and TCP. Even though the REST API is the primary mode for communication, the Docker daemon can listen to the remote API requests via 3 different types of socket: Unix, TCP, and FD. This information might not be there on the slides, but I specifically mentioned this a couple of minutes back. And folks, that is why I request you to please be attentive in class. So moving on to our next topic, let me tell you what are images and containers. Images can be related to an executable file. Images are the building blocks of a Docker container. These Docker images are created with the build command, and these read-only templates are used for creating the containers by using the run command. Containers are the ready applications which are created from the images. Containers are instances of images, and they hold the entire package that is needed to run the application. The Docker registry is where our images are stored. The registry can be either a user's local repository or a public repository like a Docker Hub, so that multiple users can collaborate in building an application. Even multiple teams within the same organization can exchange or share containers by uploading them to the Docker Hub. Docker Hub is Docker's very own cloud repository, very similar to a GitHub. Let us now understand the Docker architecture in detail. We have a Docker client, a Docker host running the Docker daemon, and a Docker registry. The Docker daemon is responsible for the images and the containers. Now if I have to build a Docker image, I will use the CLI to issue a build command to the Docker daemon. The Docker daemon will then build an image based on my inputs and save it in my registry, which can be either a Docker Hub or my local repository. If I do not want to create an image, then I can just pull an image from the Docker Hub, which would have been built by a different user. And finally, if I want to create a running instance of my Docker image, I can issue a run command from my CLI, which will create my container. This, my folks, is the simple functionality of Docker. Okay folks, it's time for a couple of more questions. Which of the below options is correct with respect to creating Docker containers? I can build my own image and use it for creating a Docker container. I can pull an image from the Docker Hub and then run the Docker image. Or I can directly create a Docker container without the Docker image. Do take your sweet time and comment your answers. Both option 1 and option 2 are correct because you first build your image and then you create a container. If you don't want to build your image, you can just pull an image from the Docker Hub and then run that image and create a container out of it. But the third statement says that I can directly create a container without the Docker image. This statement is false. And that's why the first two options are correct. Now let's move on to the next question. Where does the Docker daemon store the Docker images? Is it in the Docker client from where the users type the commands? Or is it from the Docker host which is running the Docker daemon? Or is it the Docker registry? The correct option is Docker registry. All the Docker images are stored in the Docker registry, which can be either a local repository or a remote Docker hub. This is the second section of the video where I will be showing you some practical hands-on. These are some of the basic commands in Docker. To pull a Docker image from the Docker hub, we can use the command docker pull image name :tag. The tag specifies the version of the image. The different versions of the image are identified by the tag. To run that image, we can use the command docker run and image name or docker run the image ID. To list down all the images in our system, we can give the command docker images. To list down all the running containers, we give the command docker ps, and to list down all the containers whether they are running or not, we give the command docker ps-a. Now let me run a sample hello world container and show you how Docker works. Let me go to my terminal. So here I am in my terminal. Let me first run the command docker images. This lists down all the images that are in your system. Since there are no images, there are no entries for me. Same thing with docker ps. As you can see, there are no running containers. So there are no entries. Let me show you by running a sample hello world container how Docker works. The command is docker run hello world. Since the hello world container is not present in my local repository, it will pull this container from the Docker hub. As you can see, it says pulling from library hello world. This is the image and it says pull complete. And here is your message, hello from Docker. This message shows that your installation appears to be working correctly. Now let me run the docker images command again. As you can see, there's a new image that's created with this ID. Let me do the docker ps command. And this is the hello world container that's created. Now that you know what are Docker images and Docker containers, let me show you how to build your own Docker images. Images are comprised of multiple layers, and each layer is an image of its own. They comprise of a base image layer which is read-only. Any changes made to an image are saved as layers on top of the base image layer. The containers are generated by running the entire set of image layers which are stacked one above the other. For the demonstration purpose, I'm going to show you how to run a Tomcat instance on your local system. I will be configuring this Tomcat in an Ubuntu image. To build an image, we have a Docker file. The Docker file is used to install applications and build new images. The Docker files contain instructions for building a Docker image. These instructions contain various keywords like from, run, and many more. From indicates the base image from which the container is built, and run indicates the command that needs to be executed on that image. For the demonstration purpose, I am going to show you how to run a Tomcat instance on your local system. I will be configuring Tomcat in an Ubuntu image. To build Tomcat in an Ubuntu image, we use a Docker file. The Docker files contain instructions for building a Docker image. These instructions contain various keywords like from, run, and many more. From indicates the base image from which the container is built, and run indicates the command that needs to be executed on that image. Let me now show you the Docker file that I have created for the demonstration purpose. My Docker file is present in my demos folder. So let me first clear the screen. and go to the demos folder. I'll do a gedit, Docker file. From Ubuntu indicates that I wish to use Ubuntu as my base image. Tomcat will only run if I have Java present, so I need to make sure to install both Java and Tomcat in my Ubuntu image. And as you can see, there are 3 run commands. My first run command is to add a Java repository, my second run command is to install Java, and my third run command is going to install my Tomcat. This is the command to add a Java repository. Along with this, I will run an apt-get update command first and then install curl. I installed curl because later on I will be using curl to download the tar file of Tomcat. These are the commands that will manage the repositories from where we install the software. And this command is used to create the Java repository. Now to install Java, this is the command used, and these are the other licenses which are involved to install Java. So the third run command, which will install my Tomcat, will first create a directory. It will create a Tomcat directory in which it's going to download the Tomcat tar file. It will download the tar file using curl, and it will untar the package using this command. Then I'm going to use the rmrf command. The Tomcat users.xml file has the properties to manage the roles in the Tomcat. So this command is going to copy the properties in this file to this particular location. Let me show you the properties in this file. As you can see, these are the properties to set the roles. These are the different roles: Manager GUI, Manager Script, Manager JMX, Manager Status, Admin GUI, and Admin Script. I am assigning the same username and password to all the roles in this line. As you can see, I'm separating all the roles by a comma. Manager GUI is one, Manager Script, Manager JMX. These are the different roles, and I'm separating them with a comma, and I'm assigning the password Edureka and the username Edureka to them. So the next command in my Docker file is the expose command. Expose is used to ask Tomcat to run on the 8080 port. After that, I set my environment variables for Java. Then I have the cmd command. The cmd command specifies the entry point in a Docker file. I use the cmd command to start the catalina.shell file in the bin folder by specifying run. Now that my Docker file is ready, let me build my Docker image. Let me go to my terminal. I'm going to clear the screen. The command to build the Docker image is docker build -t and the image name :tag, and I give a dot specifying that my Docker file is present in this folder, in my demos folder. Enter. As you can see, the base image that is being used is Ubuntu, and it's pulling all the layers. This is going to take some time. So my first pull is complete. Now it's running the apt-get update, and it's going to install my curl. Okay, the first run is complete, and now is the third run. In my third run, my Java is being installed. So my fourth command is running now. This is where my Tomcat is installed. As you can see, my image has been successfully built. Now I can run my image. The command to run my image is docker run I'll give a -p 8080:8080. This is to map my container port to my host port. Folks, do note that I have used a -p flag here, where the p is lowercase. Now, only if I'm using a lowercase p flag will I have to mention the host port on which I want the instance to run. Whereas if I use an uppercase p flag, then the command will return the default host port to which the container has been mapped. And then I'll just give it a name, Vardhan, and the container name. As you can see, my server is up and running. If I open it in a new terminal, if I do a docker ps command, you can see there's one container that's up and running. The Catalina shell is running and it's active on this port of mine. So I'm going to copy this. I'm going to my web browser and paste it here. Now if I go here, I would find my Tomcat is configured. As you can see, my Tomcat is configured. Let me go to Manager App and all my roles are visible here. So folks, this shows that Tomcat has been successfully configured. I downloaded the Ubuntu image and I installed Tomcat on that and I created a new image. And I created a container out of the new image. So this is the ID of the container and this is the name of the image. We can just start or stop containers by just running a command from the terminal. We need to specify the container ID as the parameters. To stop a container, I can just give a docker stop and the container ID or the container name. And if I want to remove the container altogether, then I can do a docker rm and the container name or the container ID. To delete an image, I can do a docker rmi and the image ID. But do remember that I cannot remove a running container. So I need to first stop the container and then give the rm command to remove the docker container. Let me show you that in my terminal. This is the ID of my running container. I'm going to copy this and I'm going to do a docker stop. So this is going to stop my Tomcat. Yeah. Now if I go here, you can see my container has been stopped and I've exited that container. Now let me do a docker ps command. As you can see, there are no containers running. If I do a docker ps -a, it will show all my containers which are exited. So I have a hello world command and a Tomcat container which I created. So I can delete these containers by giving the docker rm and the container ID. I'm going to copy this and paste it here. So that's removed. In the same way, I'm going to copy this, do a docker rm and paste the container ID here and I'm going to remove it. So now if I do a docker ps -a, I'm not going to find those containers. Similarly, my docker images are here. I can also remove my docker images by giving the docker rmi and container ID and image ID. Let's revise some important topics around Docker functionality that we learned earlier. The Docker daemon is the process which runs on the host machine. It manages different Docker objects like images, containers, networks, volumes, data, etc. The Docker client is the command line interface using which the users will communicate with the Docker daemon for managing various objects like the images and containers. The Docker images are the read-only templates which are used to create the Docker containers. The Docker image is an executable file built by packaging all the application and the features. The Docker registries are where the images are stored. You can store the images in your local repository or in the Docker Hub, which is Docker's very own cloud repository. Containers are the run component of Docker and the actual running instances of images. Okay folks, that is the end of our session. And these are the topics that we covered today. First, I told you the difference between containerization and virtualization. Then I spoke about Docker, and then I told you the difference between Docker containers and virtual machines. I then told you what is Docker's role in DevOps, and I spoke about Docker Engine. I spoke about Docker images, containers, and registry, and finally I finished the session by talking about Docker's working architecture. Then I also showed you hands-on where I told you how to build your own Docker images and spin containers out of them. Okay folks, these are further questions that can test your learning. Please take your time to understand the questions and then answer them. You can put the answers in the comment box and I will validate your answer. You can also comment your doubts and queries to which I would respond at the earliest. I hope this video helped you understand some important concepts around Docker. If you are interested to learn more about Docker, you can check out our DevOps course at www.edureka.co/DevOps. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!